दीप्यते। ॐ शान्ति शान्ति शान्ति। हरिः ॐ तत्सत्। श्रीरामकृष्णार्पणमस्तु।
Thank you, boys. I now request our respected principal, Swami Ekotchitananda Maharaj, to deliver his welcome address. Maharaj, please.
Om Namo Bhagavate Ramakrishna. My respectful pranams to revered monks. Our secretary Maharaj is there, other elderly monks are there, our brother monks and brahmacharis are there. My namaskar to the juniors. My respectful namaskar and regards to Professor Sven Lidin, the living legend who is present amongst us today. We have our illustrious alumnus, Professor Parthapratim Jana. And I actually don't feel like saying anything because it's a moment of joy and the stage is Professor Lidin's. He should have maximum time. Only thing I can say is that I all feel blessed because Swami Vivekananda conceived a harmony between the East and the West. The best elements of the East should be synthesized with the best elements of the West so that a new era is ushered in with the proper synthesis of Eastern prudence and Western science and technology. That's what he dreamt of. And today's seminar is a humble effort towards that direction. We're extremely happy, we're extremely glad that Professor Lidin has kindly agreed to be in our midst. Our heartiest welcome on behalf of the college family, on behalf of the IQSC, on behalf of the Department of Chemistry. And we're as well happy to have Dr. Jana amongst us as sort of coming back to his home. And definitely their illustrious, luminous presence will inspire our youngsters in their pursuit of knowledge. That's what my prayer, that's what my expectation. My pranams and namaskar in due places. Om Shanti 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 Harihi Om.
Thank you, Maharaj, for your hearty welcome address. I now request respected Brahmachari Akhanda Chaitanya Maharaj, the coordinator of the exam cell of our college, to felicitate our distinguished guest. Maharaj, please. Thank you, Maharaj, and boys also. And I now request Dr. Vikas Varun Ghosh, Head of the Department of Chemistry, to deliver introductory speech.
Good afternoon. As an ex-student and faculty of the Department of Chemistry, Ramakrishna Mission Residential College, Narendrapur, I feel honored to welcome the respected speaker, Professor Sven Lidin, revered Secretary Maharaj, revered Principal Maharaj, Vice Principal Maharaj, my teacher, Dr. A.B. Shaha, other teacher, Professor Bagchi, Professor Bhattacharya, Prashantoda, my dear Prashantoda, our dear, and my learned colleagues, Sannasi brothers, and my beloved students. The Department of Chemistry of Ramakrishna Mission Residential College came into existence in July 1960. Dr. Devkumar Mitra, the first head of the department, has guided and raised this department to a respectable height with his able leadership until the end 70s. At the beginning of 1967, Emeritus Professor Dr. Pratul Chandra Rakshit, an outstanding scholar and legendary teacher, joined the college. My teacher brought a new lease of life to the department with his illuminating method of teaching and continued his honorary service till early 90s. Dr. Kanhaiyalal Roy and Dr. Amalendra Banerjee had strongly impressed students by their innovative teaching for several years. Both of them were honorary guest teachers of this institution. The department deeply acknowledged the services of two successive heads of the department, Sri Shamar Kumar Chakraborty and Dr. Prabhat Kumar Mandal, a prestigious Premchand Roy scholar, and other respectable professors. Dr. Aragya Bharam Saha, DSc, myself, of the University of Calcutta, took the responsibility as the head of the department in the middle of 1998. And he added immense prestige to this institution in general and to this Department of Chemistry in particular. During his tenure, postgraduate course was introduced in 2005 by some talented and dedicated teachers under his leadership. At this juncture, the department took the initiative to enhance the full-fledged research activities. In this regard, the contribution of Dr. Prashant Ghosh, unfortunately he is not here, he is engaged in some symposium in ISC Bangalore. The prestigious Humboldt Research Fellow should be acknowledged. He is a dedicated research scientist and he established his modern inorganic research laboratory. Dr. Ghosh also received some prestigious awards including Shiksha Ratna Sammanana from Higher Education Department, Government of West Bengal. Now, Dr. Joykrishna Maiti, Dr. Indrajit Saha, and Dr. Muhammad Asif Ali established their organic research laboratory also. Over the years, the students of this department have been performing outstandingly, not only in university exams, but also in national level examinations, as for example IIT, JAM, NET, TIFR, GATE, etc. Every year, significant number of students are joining for PhD program in reputed national and international institutions and universities abroad. The outcome of such dedication and relentless efforts of teachers and students is reflected in the excellent placement profile of the alumnus, and I am proud of Dr. Partharuddin Jana. He is my student and our alumnus also, and already Rothil mentioned it, of the alumnus of the department. Nowadays, we find our students occupying important positions with high achievements at many renowned institutes and industries across the globe. Thank you all.
Thank you, Dr. Ghosh. The talk by Professor Sven Lidin is just about to begin. Before that, I would like to request Dr. Parthopratim Jana to formally introduce Professor Sven Lidin to the audience.
Thank you, sir. It's my immense pleasure to be here and to introduce my postdoctoral supervisor among my teachers to whom I have learned chemistry. So, Professor Lidin is a professor of inorganic chemistry in Lund University. He actually completed his undergraduate education from the same university in chemical engineering in the year of 1986. Then he moved to the same university. Then he joined in inorganic chemistry for his PhD, and in 1990 he completed his dissertation thesis. After completion of his PhD, he moved to ANU Canberra, Australia, for his first postdoc in 1989, followed by Max Planck Institute for Solid Research at Stuttgart in 1990. So in 1991, he returned back to his hometown, rather say the same university, Lund University, and he joined as a docent in the year of 1991. In the same year, he is appointed as assistant professor in inorganic chemistry in the University of Lund. And there he served at the same position up to the year of 1996. In the same year, he moved to Stockholm University and he was appointed as a full professor of inorganic chemistry. And there he served for the period of 15 years. After serving the Stockholm University, he again moved to Lund University in 2010. And currently he is working in that university. So Professor Lidin is known in the world for his contribution in structural chemistry, more specifically in aperiodic crystallography. So he published more than 300 scientific journals in his research areas. So he is the member of many scientific councils, say for KAW Foundation, Werner Brun Foundation, and he was the elected member of Swedish Research Council from 2001 to 2003. He himself has been awarded. He himself received the Nobel Extern Medal by Swedish Research Society in the year of 1999. And in 1997, he was awarded Göran Gustafsson Prize by Royal Swedish Academy of Science. In 1990, he was bestowed Fabian Gyllenborg's Prize by the Royal Swedish Physiological Societies. So he has several administrative experiences in both Lund University and the Stockholm universities. He was the former president of International Union of Crystallography for the period of 4 years from 2018 to 2021. From the age of 40, he was associated with Nobel Foundation. Still, he has an association with that foundation. And during this period, he was a member of Nobel Committee for Chemistry for the period of 10 years from 2003 to 2015. And in this period, he was chaired the committee from 2011 to 2013. So with these few words, I would request Professor Lidin to enlighten us with his experience with the Nobel Foundation here. Thank you.
Thank you, Dr. Jana. Now it is the time for the main lecture. I request Professor Sven Lidin to deliver his talk. Professor Lidin, do come, please.
Thank you.
So, thank you all for turning up here. It's
It's a great honor to speak for a full audience, and I would like to begin by thanking you for coming and for all the kind words that were spoken before my talk here. Now, I will try to convey to you how the Nobel Prize works, and to give you a step-by-step guide on how to get it. Right, so this is a picture of the floor in the concert hall of Stockholm, and this is where the Nobel Prizes, except for the Peace Prize, which is given in Norway, this is where the prize is handed over from the hands of His Majesty the King, and that's a good place to be if you're a chemist. Now, the work involved in selecting the candidates is actually done by several different organizations. So the Nobel Foundation is an organization that handles the legacy of Alfred Nobel and handles the finances of the prize and the practical arrangements around the prize. But there are several different organizations that do the actual work when it comes to the selection. The Royal Academy of Sciences is the body that does the groundwork for the prizes in physics, chemistry, and the Economy Prize in memory of Alfred Nobel. The Medicine Prize is given out by the Karolinska Institute, a medical institute in Stockholm, and the Literature Prize is awarded from the Swedish Academy of Letters. And as I mentioned earlier, the Peace Prize is handled by the Norwegian Nobel Committee, and that actually serves directly under the Norwegian government. So, how does it happen? In October every year, there is an announcement. This is the announcement, I guess, 13 years ago by now. A much younger me with hair is announcing the prize that was given to Dan Shechtman for the discovery of quasi crystals. But let's begin even earlier than that. So, why is there a prize at all? What is the Nobel Prize? And interestingly enough, I think, it has to do with Sulman, who was the chief engineer of Nobel Industries, and a lot of bad press that Alfred Nobel received. Alfred Nobel was an industrialist, and he had a huge portfolio of inventions. The one that made most of his fortune was dynamite. At the time of Alfred Nobel, explosives were very unsafe. And nitroglycerin was used, and nitroglycerin is a chemical that you shouldn't make if you're a chemist. It's very, very dangerous and difficult to control. And what Alfred Nobel managed to do was to tame nitroglycerin in the form of dynamite, which is done by having it adsorbed into silica gel. And there it's rendered not harmless, it's still a very powerful explosive, but it cannot be set off by a simple shock like nitroglycerin. And in fact, the wealth generated by Alfred Nobel at the time was absolutely stupendous. It would be equivalent to the gross national product of a small European country at the time. And so when he decided to create the Nobel Prizes, he had the financial muscle to do so. The bad press is a rather interesting story. So Alfred Nobel spent many years of his life in Paris, from 1874 to 1891. And one morning at breakfast, he opened his morning paper and he read his own obituary. The French press had made the mistake of thinking that Alfred Nobel's older brother was Alfred Nobel.
And the headline ran, "The Merchant of Death is Dead." And this set Alfred Nobel thinking. It's not necessarily the kind of obituary you want to read. No, you don't want to read your own obituary, but if you have to read it, at least it could be something nicer than that. And so being branded the Merchant of Death set him on a path of thinking how he could use his wealth for something good. He had been thinking along these lines for a long time, but this surely was a wake-up moment. And he decided that he should create the prizes for the benefit of mankind. Let's get back to Sohlman. So why is Sohlman important in this? Well, Alfred Nobel's will was contested. And it's very interesting that Alfred Nobel was living in France at the moment. He had very little connection to Sweden. Actually, Alfred Nobel didn't live very long in Sweden. He was a citizen of the world. But all his holdings were in France and in French banks. So on his death, Sohlman was appointed the executor of Alfred Nobel's will. And since in the will it said that these prizes should be given out from Sweden, Sohlman set about to gather up all the wealth of Alfred Nobel from the French banks. So around he went in a horse-drawn carriage, from bank to bank, extracting the bonds and shares and money that Alfred Nobel had deposited there. And then he smuggled this across the border because the French government considered Alfred Nobel to be a French citizen. And they considered Sohlman's activities, once they came to light, to be a theft of French property. So Alfred Nobel was born in Stockholm. He lived there for only 5 years before moving to Helsinki and then to St. Petersburg, because the family had large business connections in Russia. He moved from St. Petersburg in 1861. And he then spent 4 years in Stockholm. And during this time, he made the discovery, or the invention, of dynamite, but he also had one of his factories blow up in the center of Stockholm. And this made him a rather unpopular figure, and he moved away from Sweden. He moved to Hamburg, to Paris, and finally he lived out his life in San Remo. But he happened to be in France on the day of his death. Now, again, the Nobel Prize could very well have been a Finnish prize, or a Russian prize, or a French prize, or a German prize. The association with Sweden is rather weak, but there was ancient Swedish legislation that was still in force in these days. And according to this, a man's home is where he keeps his horses. And Alfred Nobel owned 2 Russian Orlov stallions, and those he had at his manor in western Sweden. He hadn't been there for 30 years, but he was still a Swedish citizen because that was where his horses were. And so the money, the money stayed in Sweden. The second thing, of course, is his will. If you're not able to read this, you are excused. The typing is actually very bad. And I think it's worthwhile to, let me see if I can highlight this. There are several changes and amendments. There are notes made in the margin here. Some extra text here. I doubt this would be accepted as a legal document today in Sweden. To make it a little bit easier to read, I have typed it here, and I also translated it from turn of the century Swedish to rather more modern English. I hope that helps. So, what he wrote in his will was, "I, the undersigned, Alfred Bernard Nobel, do hereby, after mature deliberation, declare the following to be my last will and testament, with respect to such property as may be left by me at the time of my death, and that is roughly 30 million Swedish crowns, which was a huge fortune at the time. And here comes one thing that was very controversial. To my nephews, Hjalmar and Ludwig Nobel, the sons of my brother Robert, I bequeathed the sum of 200,000 crowns. That's a sizable amount, but just a small percentage of his total wealth. To my nephew Emmanuel Nobel, the sum of 300,000 crowns, and to my niece Nina, 100,000 crowns. To my brother Nobel's daughters, Ingeborg and Tyra, the sum of 100,000 pounds each. That was what he left to the family. And that was a very sizable fortune. But then comes the next part, which is right here in the will. And again, I'll make the translation. The whole of my remaining realizable estate shall be dealt with in the following way. It should be given in prizes to those who during the preceding year shall have conferred the greatest benefits to mankind. Then there is some more text, but then comes an interesting part at the end. It's my express wish that in awarding these prizes, no consideration whatever shall be given to the nationality of the candidates, but that the most worthy shall receive the prize, whether he be Scandinavian or not. At this time, Scandinavianism was a hot topic. There was lots of attempts to construct a union in Scandinavia of the countries, and Alfred Nobel was a strong proponent of this. But it's important to note that this is the first ever international science prize. All previous prizes had been by necessity given within the nation. And this made things a little bit difficult for Sulman, who was the executor, because the King of Sweden was not very happy about this. He considered that Sweden would look silly if it would part with its wealth to foreigners, because there was a risk that the most important findings in physics, chemistry, medicine, or literature should be Swedish every year. And of course he was right. It's rather rare that Swedes receive the Nobel Prize. But of course it was a stroke of genius from Alfred Nobel in order to create some enduring legacy. If it had been to Swedes, no one would have really bothered about it. Although it was a sizable amount of money, national science prizes abound. The fact that he said he be Scandinavian or not should not be read into saying that Alfred Nobel thought it could only go to male recipients. This is just how the language was used at that time. He means he or her in this context. Actually, this is rather easy, because prizes to those who during the preceding year shall have conferred the greatest benefit to mankind means that we look at something that awards what has already been done. So the difficult things that we do in the scientific community is to evaluate potential, to award scientific grants to someone who says, I am going to do this. And then we have to evaluate how likely it is that this is going to succeed, and how important that work is. To foresee the future is notoriously difficult. The Nobel Prize is retrospective. We look back, and then often we look back rather far in time, which means that it's easy to tell if this was important or not. The second thing that makes this easy is that in writing what he did, my express wish is that in awarding the prizes, no consideration shall be given to the nationality of the candidates, but the most worthy shall receive the prize. Well, that means that the Nobel Prize should not pay heed to political, national, or racial considerations. It should look at the scientific achievement, or in literature, the quality of the written word. This makes things much more easy for the Nobel committees that work with actually trying to find worthy winners. There are always worthy winners. There is always an abundance of worthy winners. So it's not enough to do good work. You also have to be a little bit lucky. Now, the criteria for the different prizes actually vary quite a bit. So in chemistry, the prize is given for discovery or improvement. Alfred Nobel was a chemist himself, and he was aware of the fact that discoveries in chemistry are rare. Most of the things build on the discoveries of others. And this means, in one way, there is nothing new under the sun, but sometimes things are a little bit newer than otherwise. So, discovery or improvement. In physics, since Alfred Nobel was also an inventor, he thought that discovery or invention should be a good idea. And so there are subtle differences here. However, in medicine or physiology, he just wrote discovery. Because medicine at the time was a very, very young and immature science. And in principle, every time a qualified physician met a patient, they found something new. There were so many unknowns, there were so many things happening that medicine or physiology was a completely white page. And so discovery was enough. How does this happen? Well, in one sense of the word happen, this is how the work as such takes place. So the first thing that is needed is that somewhere in the world, someone needs to be willing to fund science that doesn't have a clear purpose of use. It's fine if the Nobel Prize is useful, but the important thing is that it's a door opener. Or perhaps not even a door opener. Perhaps the person who points out that there's a door over there can get the prize. It's much more about showing what the possibilities of science are than developing a full-fledged technology. Quite often, the prizes are awarded to a group of people who do these things, all of these things. So, discover the door, open it, and invite the public in. The second thing that is needed is that a scientist needs to use this freedom to do research, to really do something new. And that takes courage. Because even though there may be funds around for doing blue skies research, it doesn't mean that everyone is prepared to do so. Most of us tend to take the safe route, to turn the handle and produce some more of that which we have done before. And that does advance science, but not in quantum leaps, but in small steps. That is also needed, but the Nobel Prize awards the quantum leaps. And so it requires a lot of courage to do this. And the third step is that about 25 years later, the Nobel committees wake up from their slumbers. It's not quite true. It takes a long time, and I will get back to why it takes such a long time before a prize is awarded for a great discovery. If we're looking in practical terms of how this happens, during a year, we start around the mid-September, and we send out forms for nominations, because you cannot get the Nobel Prize unless you have been nominated for the Nobel Prize by someone else. Self-nominations are not considered. There is a very large number of people who are invited to nominate every year, between 3,000 and 4,000, These are divided into a number of categories. The largest category is universities around the world. And this list is renewed every year so that universities get a chance 1 year to have their say concerning whom they think is worthy of a Nobel Prize. In February is the deadline for the submission, and that's when the Nobel Committee starts working with the coming year's prize. It's not quite true, and I'll get back to that. But that is when we go through all the nominations that have come in. And every candidate who is nominated by someone else than themselves will be considered and evaluated. So it's a huge task. The first year you serve on the committee is like watching the waves go over you and wondering how everyone else can be so calm. After a few years, you learn the ropes and you know a little bit more about what's going on, but there is a steep learning curve. During this spring, we are then also consulting with foreign experts, because the Nobel committees consist of 6 to 8 people in each of the subjects. And this means that we certainly don't know everything. We know a little bit about chemistry in the chemistry committee, but we know of people who know more. And so we consult with foreign experts, we invite them to write reports, and we ensure that these reports will be secret for 50 years, at least, and longer if the people involved are still alive. And this is very, very important. If we get back to my discussion of when we hand out research grants, normally research grants are handled by senior scientists, and they handle grants for more junior scientists. But for the Nobel Prize, you're handling someone who is more senior than most of us ever are going to be. And the experts we ask have to stick out their necks if they're going to give us an honest opinion. And we're only served if we get honest opinions. That's why we need to protect their integrity and their identity, and not say anything about how that process works. The secrecy around the Nobel Prize is primarily for the sake of getting good reports. The reason why the prize is secret until the last minute is that it hasn't been decided yet. So the press conference for the Nobel Prize is held directly after the decision in the various deciding bodies. So chemistry and physics in the Royal Academy of Sciences. There is a meeting with the whole Academy in the morning. The prize is decided upon, and then the press conference is held half an hour later. So before that, no one knows who is going to get the Nobel Prize. After these consultations, the Nobel Committee decides on a limited number of proposals to forward to the Academy, and then there is a writing of the report over the summer. In September, the committee submits its recommendations, and in October, the Academy, in the case of the Chemistry Prize, makes its decision. And then in December, there is a party. People step up to the concert house that I showed you before, and everyone dances and sings. But this is a very, very simplified picture, because in fact, it's not a spiral as it's shown here, it's a full circle. Because the work on evaluating candidates lasts for much, much longer than half a year. Typically 5 to 10 years. Because when it comes to the attention of the Nobel Committee that a particular discovery is turning out to be very, very important, This is not necessarily something that strikes the scientific community immediately. There are examples where we have seen that response is very, very quick. So the CRISPR-Cas discovery on gene editing, it was immediately clear to the scientific community that this was a fantastic breakthrough. The word to CRISPR something appeared in the English language within a year. It was a breakthrough in biochemistry laboratories all over the world. Everyone understood that it was a question of time and nothing else. The Higgs boson was discovered at CERN, and the year after, the prize was given to the two who had predicted its existence. But that prediction was 40 years old. They were awarded 40 years after their prediction. But until then, it was a prediction. After the discovery at CERN, it was a discovery. But I think it's interesting to note that the prize went to the two people who predicted it correctly in all aspects. The rest was really just technology, but very, very advanced technology. But typically this circle goes around, as I said, 5 to 10 years. After deciding this is something truly important, then the committee has to work on finding out who did the job. Because after 10 years, the waters have become muddled. And you need to do a little bit of archaeology. There is often a prevailing view of how this happened. And that is often not correct. It's not always the person who was the loudest proponent for something who made the most important discoveries. There can be those who are retiring and more silent and still make the most important contributions. And it's very important to make sure that we find these people, those who made the initial discovery. And I'm not saying that we are infallible, but I will not cite any mistakes. In practical terms, and numbers, you can say, as I said, 3,000 to 4,000 invitations are sent out. Normally we get about 600 nominations in. Most of the people who are invited to nominate don't do that. It's not a major problem because we simply scale the number of invitees to the quality of the numbers that we get, so that we get a handleable number of nominations to deal with. And 600 is something we have learned to live with. We may be up at 700 these days, but these are very approximate numbers. And then these 600 nominations carry about 400 candidates. So many people get multiple nominations. Many people get one nomination. We solicit reports from reviewers, and we write our own reports as well. And in that way we can cover all the candidates one way or another to decide whether these contributions were important enough during this year's deliberations. Because then we have to do everything over again the next year. Then things have changed. There are some interesting trends and challenges when it comes to the Nobel Prize. One is small or large groups. The prize cannot be split among more than 3 legal individuals. I write legal here because there is no rule saying that the prize cannot be given to an organization. The Peace Prize is regularly given to organizations, whereas the science prizes have always gone to individuals. This is also true for the Literature Prize. But how do we deal with a group that is larger than us? And the simple answer is that we can't. If we identify clearly that there are 5 people who contributed equally to this, then the discovery cannot be awarded with a Nobel Prize. Personally, I think this is a very good idea. It would be harder and harder the larger the number of people you would include as individuals in a prize constellation. By having 3 as an arbitrary number, it was decided by the Swedish government in the 1960s, and it will take a government decision to change it. But the idea behind it is that it should be identifiable. It should be people who, particularly young students and young scientists, can identify with. We need heroes in science, we need gurus. We need people we can look up to and trust, and who we think have acquired the knowledge needed to do really great science. And then individuals is very important. The second, 25 years is sort of a median time, how long it takes before work that was done is awarded by the Nobel Prize. And it's unfortunate that it's 25 years, I would say that, because it means that one criterion for getting the Nobel Prize is that you live to a high age. So good health helps a lot. There is actually only one way to be absolutely certain to get the Nobel Prize. Anyone knows? No. So make sure that both your father and your mother got it, because then you will get it. There is only one married couple with children who both got the Nobel Prizes, and their daughter, Irene Jolie-Curie, got it as well. But it may be late for you to ascertain that right now. And therefore, we have to go back to, so why does it have to take 25 years? Well, as I said before, it takes a certain amount of time before most discoveries or inventions come to maturity, so that we understand how important they are. If you look at this year's physics prize, which is for the basis of AI and for the use of AI in physics, these are results which are quite old, but they didn't come to maturity until now. It's not until the big breakthroughs with ChatGPT, AlphaFold 2 and so on, that AI has become a real force to reckon with in science. And yet, we need to look at who decided on opening that door. Well, those are the people who are awarded. Then, even though we have waited for a substantial amount of time before awarding, we have to do the homework and make sure that we identify the right people. And so again, we are waiting. And that's why we end up with waiting times that can be quite long. The third, rather difficult question is, so what is chemistry, physics, and physiology or medicine today? When Alfred Nobel wrote his will, that was a very simple question. Chemistry was chemistry, physics was physics, medicine was medicine. Today, you will find that certainly when it comes to the Nobel Prizes, and I'm sure in your own studies and in your own research, you find that the borders between physics and chemistry are becoming very fuzzy. Chemistry uses the laws of physics to a very large extent. Physics and chemistry work together in solid state, in material science, in a great many areas. And medicine is becoming ever more molecular. Medicine is becoming a training ground for chemistry. And these are good changes. We are erasing the borders between these subjects. It also makes the work for the Nobel committees a little bit more difficult, because they also have to consider that the other committees may be working on similar prizes. But the important thing is to be inclusive. Around the world, we look differently at chemistry. And in some areas of the world, biochemistry is considered to be biology rather than chemistry. Not so in Sweden, and therefore biochemists are frequently awarded with the Nobel Prize. I would be, even as an inorganic chemist, I would be willing to defend that as much as possible, because biochemistry has shown us the way in how change can be worked in science. Biochemistry has had a fantastic journey. Just as physics had at the beginning of last century, biochemistry has had it really from the 1950s and onward. There has been this surge of results that has changed our world completely. And that's, of course, what has changed medicine as well. Extremely important, and I'm very happy that it has been embraced by the Nobel Prize in Chemistry. And there are lots of overlaps between physiology of medicine and physics as well. So the general philosophy is to be inclusive rather than exclusive, to make sure that we look at all the possibilities of what could be awarded the Nobel Prize in these categories. There's another thing that is interesting to look at when it comes to do we have to wait for 25 years? And this is again something I would like to read to you verbatim. So the Nobel Lecture, 1901, so this is the first Nobel Prize in Chemistry. It went to Jacobus von Hoff. And he began his Nobel Lecture by saying, although the investigations on which I'm about to speak were carried out 15 years ago, okay? So the first Nobel Prize was given to someone who had done that work 15 years ago. I am going to begin by describing still earlier studies, those which in fact form the basis of my own. These studies concern the experimental determination of osmotic pressure. So Jacobus von Hoff got the Nobel Prize for his work on osmotic pressure, but he was at the time 15 years old. It took 15 years to realize the importance of this, to understand that it was correct, and then he was the first to admit that this rested on earlier work. So unless we are willing to disqualify work that has long time for maturity, then we must be willing to wait sometimes. So, what chemistry, physics and medicine are today, I think, should be shown something like this. So they are making inroads into each other. They are to a large extent interdependent. And they are also interacting with other areas of research today. Certainly, mathematics, computer science, geology are areas which has served the areas of chemistry, physics and medicine very, very well. And then, of course, the question that you're all asking is this, 2025, who is going to get it? You got that? Neither did I. And of course, the truth is, we don't know. We have no idea. The Nobel Committee does not know who is going to get the Nobel Prize in 2025. It is decided in October 2025. But being in India, I feel that it is important to point out the role that India has had and has in the Nobel Prize. It's often discussed that the prize went to the German scientists, and then comes the name. And I think this is a misconception. It very seldom goes to a person who has a particular basis of operation. It almost invariably goes to people who, like Alfred Nobel himself, are citizens of the world. To have a successful research career, you need to be internationally interested. You need to go abroad and work. You need to change your environment, because that changes you. And to be willing to be changed is a very important thing if you want to be a successful scientist. I think if you want to be any sort of scientist, you must learn to accept change. And you don't go abroad because it's better, you go abroad because it's different. And that is important. Getting diverse input into a problem, getting diverse input into what is important, getting another set of glasses to study a problem is a great help if you want to do great work. So, India, and in this case, the Bengal. Rabindranath Tagore was the first non-European to receive the Literature Prize. He was actually the first non-European to receive a Nobel Prize. And as you know much better than me, he was a truly remarkable person with many, many skills apart from the fact that he was a poet. But India is a unique country in the sense that India has Nobel Prizes in all the categories, or Indians working somewhere else, perhaps. Sometimes Indians who have changed their nationality because you're not allowed to hold multiple citizenships. But, of course, Raman is a towering figure in physics, and I think it is, when I read up on Indian science, I was amazed by the slowness with which we assimilate results from other parts of the world, even though we think that science is so international. So Raman studied light and sound. And I was not aware until I read up on Raman that what led him into the Raman scattering effect was actually the study of water. And he was curious about the blue color of the sea. And there was an explanation for this. The blue color of the sea is simply a reflection of the blue color of the sky, and the blue color of the sky is Rayleigh scattering. This is wrong. And I think most people in India are aware that it's wrong. Most people in Europe are not. Because we are taught Raleigh's theory from 150 years ago, which was disproven almost 100 years ago, and it's still taught in the schools. Which tells all of you students here, be very cautious about your textbooks. The textbooks are trying to give you a nicely packaged set of knowledge. You must go out and search the knowledge yourselves. You must think deeply about science in order to do science. So Raman was the first, again, non-European to receive a Science Nobel, 1930. Then we have Hargobind Khurana for his interpretation of the genetic code, a medicine prize. We have, and now, of course, Mother Teresa was born in Albania, but she was actually born in the Ottoman Empire, so by birth she was Turkish, but of Albanian origin, and her true home will always be Kolkata. And so that was, by all reasonable definitions, that was an Indian Nobel Prize. And this was the first peace prize to India. Then a nice example of the rule that if your mother and father are Nobel Prize winners, you've got a fair chance. Well, actually, any relative will do. So Chandrasekhar of the Chandrasekhar limits, which tells us how large a star can be without being converted to a neutron star, got the prize in 1983, and he was the nephew of Raman. And very interesting for someone who's into literature, Setalaxmi, who was his mother, translated the Norwegian author Ibsen into Tamil. And this is clearly a family where people do things. The economist, Amartya Sen, got the prize in the memory of Alfred Nobel for his contributions to welfare economics. Ramakrishna, who, when he got the prize, was a British citizen, but certainly born and raised in India, got the chemistry prize in 2009 for studies and structure of the ribosome. And Kailash Satyari got the Peace Prize in 2014 as part of the team for the struggle against the suppression of children and young people for the right of children to education. I think that is particularly fitting in this setting. And the latest Nobel Prize that went to a person of Indian origin was Abid Banerjee, who got the prize in memory of Alfred Nobel in economics in 2019 for experimental approaches to alleviating global poverty. And we see how Indian scientists have made a great impact on particularly the economy of poverty. And this again shows us the importance of having global science, where you can look at different aspects of a science area and find what are the most important issues. I will show you just a few more slides before I will open for questions. You shouldn't have favorite children, but I think it's allowed to have had favorite prizes. And I think the prize for me personally, this was one of my first prizes as sitting on the committee, green fluorescent protein. It's such a beautiful prize because it started out with Osamu Shimomura, sitting to the extreme left, who studied fluorescence in general in ocean-living species. A fantastic story of a man who was accepted to the university in Nagasaki. But when he got there was no university there. There was actually no city there. And then he roamed Japan for 5 years, waiting for Japanese universities to reopen. He built a career as synthetic organic chemist. He solved problems that the big laboratories in Europe and the United States had failed to do. And then he went to work on Equoria victoria, the jellyfish. And together with Martin Chalfie and Robert Sien, this was taken from a very, very fundamental discovery to an extremely useful technique used in medicine, biology, biochemistry. This prize may be a little bit more difficult to understand, but you will see in a while. So this is Sir Laurence Olivier playing Hamlet. This is another great of the culture, Arnold Schwarzenegger playing Hamlet. And this is Dan Shechtman with his icosahedron. That gesture is so iconic. Somehow people tend to choose it to show something. And of course, Shechtman's journey from being laughed at and ridiculed for his discovery of Corsia crystals to receiving the Nobel Prize 20 years later, 25 years later, showed how he was able to move an entire very, very conservative part of science to accept absolutely new results. And I would like to finish with this year's prize, which I think marks a general change in science. This is the first chemistry prize where AI has been a very important factor. And Demi Hassabis and Johnny Jumper for the development of AlphaFold 2 and for solving the problem of protein folding. And David Baker for using protein folding predictions to construct completely new artificial enzymes, or proteins with new functionalities. Thank you very much for your attention, and I will be happy to answer any questions that I'm allowed to answer.
Sir, you are likely to take few questions from the audience.
Absolutely.
Thank you, sir. Do you have any question, particularly from the students? Feel free to ask and come on. Just come here.
Good afternoon, sir. So myself, Sony Paul, a student of chemistry of this college. So you have nicely explained the history of Nobel Prize and many other informations about it. But I have a question. Why Nobel Prize isn't given in the field of mathematics? What do you think about it?
Thank you. It's a question that many people have been asking over the time. There are false rumors that Alfred Nobel didn't like mathematics. In fact, Alfred Nobel was a very practical person. He wasn't really aware of mathematics. He didn't care about it. To him, it wasn't a science. We can think that this is a rather strange attitude to mathematics, but we should be aware of the fact that there's a famous paper from a German organic chemist, early 19th century, 1904, 1905, writing that mathematics has no role in chemistry, and when it will have a role in chemistry, it will be to the detriment of that science. Mathematics was viewed as something completely apart. And we should also remember that the revolution in physics, the new physics that emerged from 1905 and on, which relies so heavily on very advanced mathematics, that had not happened yet. And so it was Newtonian mechanics, it was relatively straightforward mathematics that was governing science. It was mathematics from the 1700s, really. All the engineering mathematics that we are taught today was being used, but this was very fundamental. And it wasn't until, I would say, 20, 30 years later that the full importance of mathematics as a common language for all the sciences became clear. Then, I think, today, I would say that there is really no need for a Nobel Prize in mathematics because the Fields Medal has all the qualities of that. And just to, again, the special role of India, you also have a Fields Medalist. I think from 2012, 13? 14, thank you. Because today, of course, we are all aware that mathematics is somehow at the root of everything. We have seen it grow to prominence not only in physics and chemistry, but also in medicine, where epidemiology is completely dependent on working mathematical models. But my simple answer is actually that Alfred Nobel was not aware of mathematics as a scientific subject at all. I don't think there was any ill feeling. He also didn't recognize biology as a scientific endeavor, nor geology. These are things that have come to fruition later on. Although all the botany was there, and perhaps the birth of modern science was the collection of plants and animals done by Linnaeus and his disciples. But Alfred Nobel was an industrialist, he was an inventor, he was very much a practical man of physics and chemistry, and these were the things that he saw. I think for him, medicine was a little bit together with peace, something that was good for humans, and that was as far as he went. So I would say it was oversight, but no malintentions against mathematics. Thank you, sir.
Any more?
Please come forward.
Sir, my question is that Sir Nikola Tesla, he he has done a lot of works in electromagnetism. He showed the world the importance of alternating current. He also tried to make the three-phase AC motors, and he did a lot of things in the field of physics and electromagnetism. So why he didn't receive the Nobel Prize?
The simple answer is I really do not know. If we look at the person with whom he had most of his competitions, Thomas Edison also did not get the Nobel Prize. I think if we look at an early stage of the Nobel Prize, there were very few inventions that were being awarded. The early Nobel Prizes in physics were, the first one was to Konrad Röntgen, and then very quickly, and I think very luckily for the Nobel Prize, the new physics became important. And I don't know, that's a simple answer, why Nikola Tesla was not involved in these discussions. There are a number of people who come up every now and then. I can answer why Rosalind Franklin was not considered for the Nobel Prize, and that was because she'd done the cardinal error that you cannot do if you want to win the Nobel Prize. She died. And very tragically, she had been dead 5 years when the Nobel Prize for the discovery of the DNA helix was awarded in 1961. But for Nikola Tesla, I just don't know. And I would say it's really interesting to see how Nikola Tesla has come to late fame, I would say, being somehow rediscovered in many other parts of the world very, very late. So of course, everyone has used a Tesla coil in physics, but the fact that he was such a groundbreaking scientist has, I think, been partially hidden by the people who then were his competitors. And if he was nominated, I do not know. I do not know about the discussions. I'm sorry I can't give you a better answer.
Thank you, sir. Anyone else? Anyone else? So, I presume that there is no more question. And let us thank Professor Lidin again with a big applause. Now I request our respected Vice Principal, Brahmachari Kedara Chaitanya Maharaj, for the formal words of gratitude. Om Namo Bhagavate Ramakrishna. There is a common quest among students community and the research students regarding the selection of Nobel laureates and the winners. And many times we do not find a research person to answer that. We are extremely delighted to have a remarkable scientist among us who has served the Nobel community for long years, whose genius in his research domain is complemented by his humble demeanor, Dr. Sven Lidin. During last 1 hour, he has provided an insightful discussion on the details surrounding the Nobel Prize and its selection process. On behalf of Ramakrishna Mission Residential College, Narendrapur, I wish to convey our deepest gratitude to Dr. Sven Lidin for his visit to Narendrapur and for delivering such a compelling lecture. It was truly engaging and filled with valuable information. The key points of today's talk include what is Nobel Prize, history of Nobel Prize, the criteria for obtaining Nobel Prize, the process of selection of Nobel Prize, trends
and current challenges and the current state of Nobel Prize. We would like to invite you again to come over here and inspire our students. We convey once again our sincere appreciation to Dr. Sven Lidin for gracing this event. Our special thanks to Dr. Partha Jana, Associate Professor at IIT Kharagpur, who was instrumental in arranging this seminar. We take pride in his achievements as a prominent alumnus of this institution, now engaged in impactful research at IIT Kharagpur. Students in the field of chemistry who wish to explore PhD or MSc project may contact him later. Our thanks to Partha again for introducing his postdoc guide, Dr. Sven Lidin. Many thanks to all the esteemed faculty members of RKMRC Narendrapur and all the professors from other institute who have joined this session. Our thanks to all the students, research scholars of this college and the students and the scholars from other institutions who have participated in this seminar. Special thanks to the students who took part in the questions and answer session. My respectful pronouns to all the monastic members present here. My pronouns once again, Prasantada, Aragada, Vijayada, for attending this seminar. My thanks to Dr. Vikas Varan Ghosh, the head of the Department of Chemistry, for briefing about the Department of Chemistry. And thanks to Dr. Rathindranath Ghosh for comparing the session. Special thanks to the photography, videography, maintenance and stage decoration team for successfully conducting this seminar. Thank you once again for attending the session. Thank you.